Happy Thursday, everybody! Okay, we are going to finish off reading Titus Rules OK today. So can you please read the final chapter for me? So I hope you've enjoyed the story. Last few questions for you today. So the first thing is, what was the Queen and Prince Philip watching on the TV? Why do you think the lady in waiting looked puzzled? Were your predictions correct that you made about the story, and can you justify your answers? So prove to me whether they were correct or incorrect. And then I'd like you to tell me which part of the story you found the most interesting or exciting, and then explain why. Okay, so the Queen and Prince Philip were watching a documentary about vandalism in inner city areas. The lady in waiting looked puzzled because the Queen had never asked for a bottle of spray paint before, and it isn't something you would ever expect the Queen to ask for. And then obviously the predictions and your choice part of the stories is completely up to you. I hope you've enjoyed reading the story, guys. Welcome to your maths for today, class 4. So we're going to explore calculating quantities today. So similar to yesterday, but slightly different. Okay.
Hello. In today's lesson, we're going to learn about calculating quantities. Yesterday we looked at fractions of quantities. Now we're going to look at calculating them. Hopefully you'll be able to see the relationships, the links between the two lessons. I've got a bar model here and a common fraction I'm sure we're very familiar with now. We've got a half, haven't we? In fact, we've got two halves. We've got one whole. Let's put a question about a half on the screen. A half of something is equal to 12. The most common error people make with this type of question is misreading the question and think, oh, it's 6, because it's asking me for what's half of 12. We looked at that yesterday, but this is not asking us what is half of 12. It's asking us half of some mystery number, some missing number, is 12. So let's think about where we're going to put 12 on our bar model. That's the question. What's the whole? And we know that half is 12. Half of something is equal to 12. So we know that that half's 12. So we know that the other half's 12. So you might well to do an addition or a multiplication that we can see here. 2 lots of 12. 12 times 2 is 24. So half of 24 is 12. And once you've got the answer to this type of question, you can read it back to yourself. And hopefully we know that half of 24 is 12. So in this case, we can just read it and see that it's correct. In other cases, you can check. You can do the calculation like we did yesterday to check that you've got the correct missing number. 1 half of 24 is equal to 12. Yes, that is correct. Let's have a look at another. Remember, we're not being asked for what's a quarter of 5. We're being told that 5 is a quarter of something, and it's that something we need to find out. So we're dealing with quarters. So let's show our quarters, one of 4 equal groups. And we know something about the quarter, don't we? We know that one of the quarters of this mystery number is 5, so let's put that in there. Well, if that quarter's 5, every other quarter's 5. So again, we can probably count up or multiply using our 5 times table knowledge. We've got 4 lots of 5 now, 4 quarters of 5. So the answer is 20. If we wanted to check, we could go back to what we did yesterday and we could calculate what is a quarter of 20. And if we get the answer is 5, we've got the correct answer there. How about this one? What's changed here? Look at the fraction. This is the first time we're dealing with a non-unit fraction. So we looked at a half, we've looked at a quarter, now we've got a non-unit fraction because we've got 2 as our numerator. 2/3 of something is 14. Remember, we're not being asked what's 2/3 of 14. We're told that 14 is 2/3 of something. Okay, so we're dealing with thirds. Let's draw our bar model, and we're dealing with 2 of them, so I've highlighted 2 of the thirds. Now, have I got my 14 in the correct place here? No, because that bar model shows a 14 is 1/3 of something. But here we're told that 14 is 2/3 of something. So we need to slightly change the bar model here. So I'm going to show that 14 using another bracket because we're told that 14 is 2/3. So how do you think we find 1/3? We find 1/3 by dividing 14 by 2. If 14 represents 2 of the thirds, 1 of the thirds is going to be 14 divided by 2, which is 7. And then the other third We know that's going to be 7. So now we're relying on our 7 times table knowledge. 7 times 3, 3 lots of 7, 21. So 2/3 of 21 is equal to 14. Your first chance now to have a practice at this idea. You've got a unit fraction and a non-unit fraction to have a go at. So number 1, we were dealing with 6 here, and we knew that each 6 was worth 9, and we had 6 of them, of course. So 9 times 6 is 54. So 1/6 of 54 is equal to 9. Number 2, slightly more challenging because we had a non-unit fraction here. So we're told that 4/5 of a number is 32. So we can see how we've shown that 32 as being worth 4 of the fifths. So we're going to divide 32 by 4, and the bar model really clearly shows us why we're dividing it by 4, not 5. You may think we're dividing it by 5 because we're dealing with fifths, but remember 32 is only worth 4 of the fifths. So to find 1/5, we divide it by 4 to get 8, and then multiply by 5 because we've got 5 of them, 40. So 4/5 of 40 is equal to 32. Another couple to have a go at. So number 3, you may have been thinking at first, oh, I've got to divide 3 by 7. No, you don't, of course, because you're told that 3 is 3/7 of something. So it's actually 3 divided by 3. Really simple, which is 1. And then 1 times 7 is 7. So 3/7 of 7 is 3, is equal to 3. 6/6 of something is equal to 48. Well, you may have done the method, and it's fine if you did, but we've talked a lot about what 6/6 means when we've got a numerator and denominator the same. That means 1 of 48. So 1 of 48 is 48. So if you did the method, that's not a problem, but hopefully some of you may have been able to say, oh, we don't need to do the method here because it's just asking us what's 1 of 48, what's 1 lot of 48, which is 48. You're now ready, if you've got the worksheet in front of you, to do the first 3 questions on it. If not, you can start the lesson on the BBC Bite Size website. When you've had a go, do come back for the rest of the video. Let's have a look at how we calculate a quantity when the fraction is improper, where we've got that numerator larger than the denominator. Like we talked about yesterday, this may look confusing, but it's just the same idea as we've looked at with proper fractions. 5/4 of something is 15, so we're told that 15 is 5/4 of some mystery number. Well, there's 4/4, and of course the question mark is there because that's what we need to find out. We need to find the whole, but we've only got 4/4 there, so we need to draw another bar divided into quarters so we can show 15 on the bar model, because 15 is 5 of the quarters. So you can see I've done my bracket for 15 covering 5 of the quarters. So now you can really clearly see what I need to divide 15 by. I need to divide it by 5 because I've got 5/4. So 15 divided by 5 is 3. So each of these shaded quarters will be worth 3. Of course, every quarter would be worth 3. We could carry on that second bar model. But we don't need to, because we can see where our question mark is. That's the whole that we need to find. So we've got 4 lots of 3 is equal to 12. 3 times 4 is equal to 12. So 5/4 of 12 is equal to 15. Pause the video, have a go at that question with an improper fraction. Okay, so 22 is 11/8 of some mystery number. So let's draw out our 8s, and we needed 11 of them, so we need to draw 2 bars. And we've got 8 of them in the first bar, and then 3 more in the second. So we put our brackets around those 11/8s. So we can see there we've got to divide 22 by 11, which is 2. And then 2 multiplied by 8, because we've got 8 of them to make one whole, is 16. So 11/8 of 16 is equal to 22. Another couple there for you to have a go at, both of them improper fractions, so you'll be needing to draw more than one bar model for each. So number 1, we can see we've got 36 divided by 9 because the 36 is 9 of the 7, so 36 divided by 9 is 4. Then to find one whole, we need to multiply that 1/7, that 4 by 7, 28. And number 2, so we've got 60 divided by 12 this time, because the 60 is worth 12/10. So 6 divided by 12 is 5, and then 5 multiplied by 10 is 50. So 12/10 of 50 is equal to 60. You're now ready to have a go at the next question on the worksheet if you've got it. That question involves this idea of improper fractions. If not, check back on the BBC bite-sized lesson. Are there any questions involving improper fractions? Come back, we've still got a few more problem-solving tasks to go on the video. So let's have a look at this problem-solving situation. Jack and Dora share a large packet of crisps. Jack eats 1/6 of the packet and Dora eats 4/6. There are 40 grams of crisps left after those two amounts have been eaten. What was the mass of the full packet of crisps? What I'm going to do is I'm going to draw that bar model. It's not fully labelled, but you might want to add some labels. So I'm going to encourage you to pause the video now, see if you can answer that question, use that bar model to help you. You might want to copy the bar model and put some more labels on to see if it will help you. Okay, so we know that there are 40 grams of crisps left, so let's show that 40. So now I think we can probably see to find the mass of the full, so that was before anyone ate anything, we're going to multiply 40 by 6 because we were dealing with 6 and there was 1/6 left. So we need 6/6, which was the starting amount. So 40 times 6, well, 40 times 6 is 24. So 40 times 6 is 240 grams. 240 grams for question 1. See if you can use the bar model to answer question 2. Well, we can see Dora ate 160 grams, can't we? 40 times 4 is 160. Jack ate 40, so Dora ate 120 grams more. Another question for you to have a go at. I'm not going to give you the bar model to use this time, but you draw it out yourself. Okay, this type of question, the labelling of the bar model is the crucial bit of the process to get the answer. Once we've got that labelling accurate, the answer is often quite straightforward. So we know that this race is divided into 8s. So there we've got our 8 pieces. After running 3/8 of the race, she's got 20 kilometres left to run. So if Alex has run 3/8, she's not run 5/8. So let's show run as 3/8, and she's not run 5/8. Because, of course, when she's finished the race, she's run 8/8. And we know something about this, how much she's left to run. We know that that's 20 kilometres. So now we can see we're not dividing 20 by 8, we're not dividing it by 3, we're dividing it by 5, because 20 kilometres is 5/8 of the race. So 20 divided by 5 is 4. So each 8th is worth 4. And of course, if those 8ths are worth 4, so are those 8ths. So then we can see the total race distance is 4 times 8, because we're dealing with 8. So the total race distance, how long the race is 32 kilometres. One more for you to have a go at. A little bit of a hint here. Do draw a bar model, as we've done before. One bit of a hint. Think about what the word regular means when we're thinking about shapes. Okay, so I really like this question because it's involving different bits of mass. So regular, when we've got a regular pentagon, we know it's 5-sided, and we know that each of the sides is an equal length to each other. So we could show that with a bar model. We know that the 5 sides are going to be the same length. So there, we've got our bar model. 2 of the sides added together are 6 meters. So let's show that. Let's put that bracket around. That's, of course, the question, the perimeter around this pentagon. And we can show that 6 because we know 2 of the sides, so in other words, 2/5 of the perimeter is 6. So now it's quite similar to the question that we just had with the race. So then we can find that 1/5 is 3, isn't it? Because we're dividing that 6 into 2. So we've got 3 meters for the other fifths. We can see 3 meters times 5 because it's a pentagon, 5 sides. So the pentagon's perimeter is 15 meters long. There we are. You now ready to finish off the worksheet?
Okay, your questions are there for you now. Pause me when you've done them and I will show you the answers. There are your answers, guys. I hope you found that all okay. Any problems, just send me an email.
Good morning, class 3 and class 4. We're on Thursday, the 16th of July. So we've got a reminder over here of the Evening Post newspaper example, because today you're going to start writing your newspaper reports. Okay, so remember your newspaper report is about the Queen's hero, Titus. Now, I gave you the choice yesterday when you were planning as to whether you wanted your newspaper report to be all about Titus stopping Sidney, the footman thief, or whether you wanted the whole report to be all about Titus and all the things he did to become the Queen's hero. So that is your choice. Now, I'm going to recommend that you take some time tomorrow to write it, because I'm not going to set you a separate task simply because it's the last day of school. But I have got something prepared in terms of making sure that you guys have a go at adding some pictures to your newspaper report. But I am happy if you want to do it all today, so you don't have to do it tomorrow. That's absolutely fine. But if you would like to break it down a little bit and really challenge yourself, then you can do half of it today and half of it tomorrow, but it'd be nice to include pictures in it as well. If that means that you have a go at drawing Titus yourself, or perhaps the Queen and Titus, that would be lovely, and that would look great in your newspaper report. So have fun today, guys. It'd be great to see if you can set it out using columns. You don't have to do 3 like in the example. 2 works just as well. If you can create your 2 columns by just drawing a line down the middle of your page using a ruler, and make sure it's set out beautifully, and have a go at using paragraphs as well. I can't wait to read these. If you want to send a picture to me or Miss Foster, we would love to read them. And I will see you year 3 for maths, and year 4, I guess I'll see you, I'll still record one for tomorrow anyway. Okay, so have fun with that then, guys, and I will see you tomorrow.